It has been 2 years since NASA's James Webb telescope gave us a stunning first look at the depths of our universe.
The world first started seeing spectacular images of the cosmos that were captured by the powerful James.
What if the most advanced telescope in history has just revealed proof that we might not be living in our universe? The James Webb Space Telescope's latest discoveries aren't just rewriting astronomy textbooks, they're shaking the foundations of reality itself. What it's found could change how we see time, space, and existence forever. And here's where it gets unsettling. A Nobel Prize-winning physicist recently broke his silence with a simple but terrifying statement. This is not our universe. Now that's not a line you hear from someone at the top of their field unless something big is going on. The James Webb Space Telescope, or JWST, was built for one purpose: to peer deeper into space and further back in time than any telescope in history. We're talking about seeing the faint light from the very first stars and galaxies formed just after the Big Bang. At least, that's what we thought. But the images JWST has been sending back, they're not just beautiful, they're bizarre. They're showing structures and objects that shouldn't even exist according to everything we know about physics, cosmology, and the timeline of the universe itself. So here's the big question. Did JWST just find something humanity was never meant to see? Something that doesn't fit into the universe we thought we understood? Or is it possible that we've been living with the wrong map of reality this whole time? Because what comes next will make you rethink everything.
Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy.
This part blew my mind. In one corner of the sky, JWST spotted what looked like just another faint yellow blob. But when scientists zoomed in and ran the numbers, they realized this wasn't an ordinary galaxy. It was the most distant galaxy ever detected, formed just 290 million years after the supposed birth of the universe. Now here's why that's a problem. Galaxies aren't supposed to grow that fast. By our current physics, there simply wasn't enough time or matter for something this massive, bright, and evolved to exist so soon after the Big Bang. And it's not just a one-off. JWST has now found dozens of these galaxies, all showing signs of being too advanced for their age. Imagine finding a fully grown adult where there should only be newborns. That's what astronomers are dealing with right now. This single discovery is poking massive holes in the Big Bang timeline, forcing scientists to consider whether the early universe worked in ways we've never imagined, or whether this early universe we think we're looking at isn't early at all. So what would you believe? The models we've trusted for decades, or the cold, hard evidence staring at us from the edge of everything?
Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
So something real is happening, but we can't tell yet if it's a mistake in our observations, a mistake in our interpretation, or just something nature is surprising us with, such as a new kind of dark matter, a new kind of dark energy, or something else that would be really exciting to discover.
Just when you think it can't get stranger, it does. Most galaxies convert only about 10% of their gas into stars. The rest stays as raw material for future star formation. That's just how galaxy formation works, or so we thought. JWST has now found at least 3 galaxies that have converted 100% of their gas into stars. No gas, no dust. Nothing is left for new stars to form. Just pure, blazing starlight. Here's the kicker. That's not just unusual, it's impossible according to every current model we have. There's no known mechanism in cosmology that could pull this off, especially in the early universe. So scientists are asking a much darker question. What if these aren't galaxies at all? Some theories are getting bold, and I mean bold. They range from these being structures from another dimension, to remnants of a previous cosmos that existed before ours, to actual intrusions from an entirely different universe. Think about that for a second. What if JWST isn't just looking back in time, but sideways into something else entirely? If that's true, then these strange galaxies aren't part of our history. They're glimpses into a reality that's been brushing up against ours this whole time. And here's where it gets even stranger. In cosmology, there's something called the Hubble sphere. It's the maximum distance we can see into space. Beyond that, galaxies are moving away from us faster than the speed of light due to the expansion of the universe. Common sense and physics says light from beyond this boundary should never reach us. Those regions are forever out of our sight. Or they should be. But JWST is now picking up light from what scientists are calling impossible zones, regions well beyond the Hubble sphere. That means we're receiving photons that should, by all current understanding, be lost to the void forever. This isn't just a little weird. It's a direct violation of how we think the universe works. It's like hearing someone whisper from a mile away in a vacuum. So what's going on? One theory is that the expansion of space isn't uniform. There might be pathways or distortions that allow light to slip through from beyond the cosmic horizon. Another, far more unsettling idea, we're seeing past the edge of our universe into somewhere else entirely. If that's true, it means our observable universe is just a bubble in a much larger structure, and JWST might have just poked a hole in the bubble wall.
Let me ask you this. Everything that you're saying,
Sure.
to be clear, we're not abandoning, are we, existing models about how galaxies form and evolve yet, right?
Well, we might have to.
Ah.
Yeah, but that's okay.
That's
not
okay.
a bad
All right.
day. That's a great day for science.
Just when scientists thought the data couldn't get more controversial, it did. For decades, the Big Bang Theory has been our best explanation for how the universe began. But now, some Nobel laureates are openly questioning whether there was a beginning at all. If galaxies could form impossibly fast, if light can reach us from beyond cosmic boundaries, if structures exist that defy time, mass, and scale, then maybe our entire timeline is wrong. One radical possibility: we're not looking at the early universe at all. We're looking at a fracture, a point where two universes overlap, or where something much older than our universe is bleeding through. In other words, JWST might not be showing us our past. It might be showing us someone else's present. And if that's the case, the Big Bang wasn't the birth of everything, just the birth of our part of it. But the weirdness doesn't stop with what we can see, it's in what we can hear too. While scanning deep space, JWST detected a faint rhythmic oscillation, a cosmic heartbeat that doesn't match any known phenomenon. It's not a pulsar, it's not gravitational waves, it's not interference from cosmic microwave background radiation. This signal repeats at precise intervals with perfect regularity, as if something or someone encoded it deliberately. Some scientists have dubbed it the heartbeat beyond time. Others are more cautious, calling it a possible signature of exotic matter, something that can only exist outside the boundaries of our universe. Here's what's freaking people out. The frequency follows a mathematical pattern, not random static, not natural chaos, a pattern, the kind of thing you'd expect from a design system. Now, no one's saying it's aliens, but if it's not natural, what does that leave? Could it be the vibration of space-time itself? Or a resonance caused by two universes brushing against each other? Whatever it is, the fact that JWST picked it up means it's real. And it's coming from a place we've never been able to reach before. And now we hit one of the strangest findings of all. JWST has observed galaxies so far away that they appear to be bending light, distorting space itself, even though there's no visible matter there to create that gravitational pull. Normally, when we see this kind of light bending, we chalk it up to dark matter, the invisible substance that makes up most of the mass in the universe. But here's the problem. These distortions don't match the behavior of dark matter as we know it. They're stronger, sharper, and they don't seem to be tied to any visible structure at all. Some researchers are now calling these phantom mass fields, massive gravitational imprints with no detectable source. It's as if something enormous is pressing down on our space-time from somewhere we can't see. So, where's it coming from? One bold possibility is that these are the pressure points where another universe is colliding or overlapping with ours. It's gravity leaking through into our reality. Think of two soap bubbles pressed together. You can feel the push, even if you can't see what's on the other side. If that's what we're looking at, then JWST may have just caught the first fingerprints of a cosmic neighbor.
Yeah, that splotch here. So it's really probing basically the earliest structures we know in the universe.
When you look at this image, there are lots of splodges all over the place. What made you look at that one in particular?
We have been seeing this object already in the very early data we obtained nearly 2 years ago. And I think the surprising thing was that it's actually very bright. And so our initial reaction was that, well, it cannot be that distant because it's too bright. And so we took better data, and in particular, we also took spectroscopy. And we could clearly see that, no, that galaxy, that this yellow blob here, is really this most distant galaxy that we have ever seen.
But wait, it gets even more mind-bending. There's a fringe idea in physics that's been around for decades, the mirror universe theory. The concept is simple and terrifying. Imagine another universe that's a direct reflection of ours, where time flows in the opposite direction, the laws of physics are inverted, and everything is, quite literally, reversed. It sounds like science fiction, but JWST's data is giving it fresh credibility. In several distant galaxies, scientists have noticed asymmetry in particle behavior and rotation patterns. Instead of the neat, predictable spin we expect from galaxy dynamics, some are rotating in ways that defy the mass distribution we can see. Even more bizarre, certain particle interactions in these galaxies don't align with how our physics says they should behave. It's as though these galaxies are being influenced by a set of rules slightly different from ours, rules that might match a mirrored version of our universe. Here's the wild part. If two universes like this were entangled, they could overlap in subtle ways, each tugging on the other without fully merging. Think of it like two hands pressed together with a thin layer of glass between them. You can feel the other side, but you can't touch it directly. If JWST is detecting the pull of a reversed universe, it might mean that our reality is only half of the cosmic story, and we've just glimpsed the other half for the first time. And now, the twist that gave me chills. One of JWST's instruments was tracking a light signature from near the very edge of the observable universe. As expected, the signal was getting weaker, fading into nothing, like all distant light eventually does. But then, it came back, not from the same spot, not from the same moment in cosmic history, but with the same spectral fingerprint. That means whatever light we were seeing the first time, we were seeing it again. So what does that mean? There are two main possibilities, and both are huge. Option 1, the universe is finite and curved, like the surface of a sphere. In that case, light traveling far enough could eventually wrap all the way around and return to its starting point, just like walking in a straight line on Earth and ending up back where you began. Option 2, the light hits something at the very edge of the cosmos and reflected toward us. And that something would have to be large enough and smooth enough to act like a cosmic mirror. The second option is more unsettling because it raises the question, what's out there that could reflect light on a universal scale? Is it a boundary, a wall, or the surface of another universe entirely? Either way, this wasn't supposed to happen. Light from billions of years ago shouldn't just boomerang back to us unless space itself is more complex and possibly more enclosed than we've ever imagined. JWST didn't just capture an image, it may have caught the universe whispering back. So let's put it all together. We have impossible galaxies, too massive, too evolved, too soon after the Big Bang. We have 100% star conversion systems, breaking every model of galaxy formation. We're detecting light from impossible zones, beyond the Hubble sphere. We're hearing the heartbeat beyond time, a mysterious patterned signal from deep space. We've seen phantom mass fields, gravity with no source. We've found signs of a mirror universe, galaxies obeying inverted physics. And now, we've caught a cosmic echo, light returning when it should be gone forever. Individually, each of these would be groundbreaking. Together, they form a picture that's almost too big to comprehend. Maybe JWST hasn't just looked deeper into space. Maybe it's looked through space, into the deeper structure behind it. If that's true, then our universe might not be a self-contained bubble after all. It could be part of a vast network, a multiverse, where boundaries overlap, bleed through, and occasionally let us peek into another reality. And if a Nobel Prize-winning physicist is right, maybe we're not in the right universe to begin with. So the real question isn't just whether we're alone in the cosmos, it's whether we're even in the right reality. In the end, the James Webb Telescope isn't just looking deeper into space, it's peering into the very foundations of reality. If these findings hold, the story of the universe may need rewriting, and we're only on the first chapter of an incredible cosmic mystery.